Hello, this is Mr. Flatness, and today's lesson talks about the least common multiple. Our goal is to use knowledge about multiplication to find the least common multiple of 2 or 3 or even multiple numbers. We'll begin by writing down some vocabulary. So to review, a multiple is a product of a number and any natural number counting by that number. So write these down in your notes. That's kind of confusing as you read it and listen to it, but then to give examples makes it more clear. So, for example, if I want to know the multiples of 3, I would literally start with the number 3. So I'm going to start with the same number and then count by 3s, or I could multiply up until I get my product. So what I mean by that is I can go either 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is 12, 12 plus 3 is 15, etc. Or I can do 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. So I can either continually add, or I can use my multiplication skills to come up with those numbers. So that would be what multiples are. Your least common multiple is the smallest number. That is a multiple of all the numbers you are considering. So let's say I want to consider the numbers 3 and 4. So I'll start out by writing those multiples. So we already know that the multiples of 3 are 3, 6, 9, 12, 15, 18, etc. I can keep going. 3 dots in a row means the pattern continues. The multiples of 4 are 4, 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, and that pattern continues. So when I want to know the lowest or least common multiple, you'll notice here that I have 12 is a multiple of 3 and 12 is a multiple of 4. So therefore I would say that the LCM of 3 and 4, that would equal 12. So, some vocabulary and then an example of how to use that skill. Students struggle with LCM and GCF and trying to determine the difference between the two. So, a hint, I would write this down in your notes, a hint to be able to kind of keep them separate would be this. Your LCM is always going to be greater than or equal to the original numbers that you're looking at. Okay? The first multiple will always be the number itself. Keeping back to thinking about the previous slide, when I was considering the number 3, my first multiple was the number itself. So if I'm looking at 3 and 4, I'm going to start that way. Well, if you remember, 12 was our LCM in both. So my LCM always has to be greater than or equal to the original numbers. So I can have a number smaller than 3 or 4 as my LCM. However, if I want to deal with the greatest common factor, that always has to be smaller than or equal to the original number, because the first factor is always 1. So if I did the factors of 3 and 4, which are different now, and I'm dealing with the groupings, I know that the factors of 3 are 1 and 3. The factors in 4 are 1 and 4, and then I also have 2 and 2. So here, if I want to know the GCF, notice the biggest common factor here is 1, which notice is less than or equal to the numbers I'm thinking about. So that's how you can keep LCM and GCF separate in your mind. So how do you apply this information of least common multiple? Here's an example that you would use an LCM skill to solve. You and a friend are skating at a park at the same time in the same location. Same time, same location is very important. You're skating the trail in 8 minutes. So in other words, just think of an oval. You go at the beginning of the trail, you loop around, you get to the very beginning again. It takes you 8 minutes to complete a lap on the trail. Well, your friend skates that same lap in 6 minutes. So again, same time, you're going at the same distance. Notice though that it takes you 8 minutes and it takes your friend 6 minutes. So your friend is faster, and will go a lap quicker than what you will. So now the question wants to know how long until you are both starting at the same point again. So when would that point be? Well, here's where I can make a list and deal with the LCMs. So I'm going to start out by writing the multiples of 6 and 8. So I'll work through the multiples of 6 and 8. Now, another skill you can use when you're listing all these multiples is start with a larger number. So I'm going to start with 8. So the first multiple of 8 is 8. 8 times 1. And then I'm going to go 8 times 2 is 16. 8 times 3 is 24. Now before I go any farther, I'm going to see if 6 is a factor of any of these numbers that I have written down so far. Okay, is 6 a factor of 8? No, there's no number times 6 that will get me 8. But if you see up the line here, 24, 6 is a factor of 24. 6 times 4 is 24. So then I know then that the number 24 will also be a multiple of 6. I'll write those out to show you. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. This allows you to condense your lists so that you don't have to write more multiples than you have to. So if you notice here, I've gotten to my LCM. 24 and 24 are multiples of both, so my LCM is 24. So what does that answer mean? What does this 24 mean? Well, again, let's look back at the question. How long until you are both at the starting point at the same time again? Well, 24 then, we're talking about minutes. So in 24 minutes time, so if you both start at the same time and started skating, in 24 minutes or at the 24-minute mark, okay, not 24 more minutes, but at the 24-minute mark, you'll be both in the exact same location again. In this next example, you'll notice that I have selected much larger numbers. And coming up with multiples of larger numbers when they're not basic facts can be difficult. And it would take a long time as well. So there's another skill that we can use to come up with this least common multiple. And again, we come back to prime factors. So I'm going to use prime factorization to find the LCM of 36 and 240, just like I used prime factorization to find the GCF of numbers. And again, I'm going to use the ladder method, which is an excellent tool. So using my ladder, I'm going to consider the numbers 36 and 24. And again, I'm going to be identifying and working with prime numbers again. So prime numbers that go into 36 and 240. They're both even, so for sure I'm going to use the number 2. And then I'm going to take 36 divided by 2. Well, half of 36 is 18. Okay, 240 divided by 2, half of 240 is 120. Now I'm going to look at the number 18 and 120. They're even, so I'm going to use 2 again. 18 divided by 2 is 9. 120 divided by 2 is 60. Looking at both 9 and 60, I know that 3 can be a factor. 9 divided by 3 is 3. And 60 divided by 3 is 20. Okay. Now you'll notice that I don't have any more in this, and here I'm looking at 2 numbers. I don't have any more prime numbers that I can look at that would be a factor of 3 and 20. So that's how I can determine that I'm done. So now what I have to do is identify one more piece, and that would be the numbers outside and on the bottom this time. So looking at that, I'll choose a different pen marker. Here are the numbers on the side, but then I'm also going to include this bottom. Okay, the numbers that I'm left with. Well, notice in red here now it looks like the letter L. So all I'm going to do now is take all the numbers inside of the letter L that I created, and I'm going to multiply them out. So I'm going to take 20 times 3 times 3 times 2 times 2. And when you multiply all those numbers together, 20 times 3 is 60. 60 times 3 is 180. Double 180, and you get 360. And double 360, you get 720. So the least common multiple of 36 and 240 is 720. So that is my LCM, 720. As you can see, way shorter than listing out all those multiples. Imagine listing all the multiples, getting to 720 for both of these numbers here of 36 and 20. That would, or 240. That would take you a tremendous amount of time. Where here I can clean it up, use prime factorization, and I can make myself have work that's a lot less. Let's try an example where there are three numbers that I want to find the least common multiple for. So in this example, I want to find the LCM of 10, 15, and 40. And again, I'm going to use this concept of prime factorization and the ladder method. So I'm going to shrink this down so that I have more room to write. So in my ladder, I have the numbers 10, I have 15, and I have 40. Again, I'm going to use prime factorization. 10, 15, and 40. We have numbers that end in 0 and end in 5. So I'm going to divide them all by 5. 5 goes into 10 twice. 5 goes into 15 3 times. 5 goes into 40 8 times. Now this next step is more important. Thinking back to GCF, you'll remember that now 2, 3, and 8, there's no number that I can divide prime number that is a factor of 2, 3, and 8. So if I were looking at the GCF, I would be done. 5 would be my GCF. However, LCM is a little different, okay? As I want to choose factors that either are going to, prime numbers that are either going to be a factor of all three, like what I did up here in the first example, but I can also look at any more common factors that might be just of two numbers. Well, if I look here, I have a 2 and an 8. And I know that there's a common prime factor of 2. So what I'm going to do then is pull out a 2. So then 2 divided by 2 is 1. This 3 that I didn't work with, I'm going to bring it straight down and keep it there. And then 2 goes into 8 4 times. Okay, so now looking at the numbers that remain, I can't find any prime numbers that go into all three. I can't find any prime numbers that would go into 2. So therefore, now I know that I'm done. So that's the biggest difference. So again, I'm going to make this letter L out of the numbers that are left over. And now I can multiply those out. So 5 times 4 times 3 times 2 times 1 would be my problem. 5 times 4 is 20. Times 3 is 60. Double that, I get 120. So the LCM of 10, 15, and 40 would be 120. So it's a little bit different. I would definitely rewind this and replay this as many times as you can so that you understand the difference of the GCF and LCM, keeping particularly in mind in that I started out finding a factor of all three, but then I progressed to finding a factor that would only work for 2 of them, not necessarily all 3. And then what I did is for the number I didn't work with, I continued and brought it down into my L. So in this example, I'm going to take my knowledge of the LCM and also using the ladder method to find the answer to this particular problem, which is a real-life problem. Your science teacher is going to give a test every 15 days. Social studies teacher is going to give you a test every 20 days, and your English teacher is going to give you a test every 24 days. So this word every here in front of the number is talking then about multiples, so that helps you understand that it's a multiple problem and not a greatest common factor problem. And then it says here to finish out, you just had a test in all 3 classes on the same day. how many days until you have all 3 tests on the same day again. So that's what we're going to take a look at, and I'm going to use the ladder method, and I'm also going to be using prime factorization. So I'm going to shrink this down so I have a little bit more room here to write. So looking at this, I'm going to consider the numbers 15, 20, and 24. On my previous example, using the ladder method, I tried to find first a number that goes into all 3 numbers. And when I look at these 3 numbers, and again I'm thinking about prime numbers, so again prime numbers I'm thinking about are 2, 3, 5, 7, 11, 13. Of those numbers that I've listed, they're not going to be a number that can go into all 3 of these numbers. So what I'm going to do is pick 2 of these 3 to work with. So I'm going to pick, first of all, the numbers 15 and 20. And I'm going to say, well, this one ends in a 5, this one ends in a 0, so I can use the number 5. So 15 divided by 5 is 3, 20 divided by 5 is 4. And then what I'm going to do is, because I didn't use this 24, I'm going to circle it and I'm going to bring it straight down here and know that I still have to work with it at some point in time. And then I'm going to continue on with my ladder. Okay, so I'm going to look at 3, 4, and 24. Is there a number that goes into all 3 of those? Well, there isn't when I look at the numbers 2, 3, 5, etc. So then I'm going to pick 2 again. So I can either choose to work with 3 and 24, which, hey, I know that 3 is a factor of both of them. Or I can use 4 and 24, because I know that there's a factor in both of those 2 as well. So to me it doesn't matter. I'm going to just work with 4 and 24. So I know then that they're both even, so I know 2 works. So I'm going to divide those by 2. So notice the number 3 that I didn't work with, I'm going to circle it and bring it down. And then I'm going to take 4 divided by 2 is 2. 24 divided by 2 is 12. And again, I'm going to be looking at, is there a number that goes into all 3? And there isn't. So then I'm going to try to work with 2 again. So you'll look and see that I can either work with 3 and 12. They have a common factor of 3. Or 2 and 12. They have a common factor of 2. It really doesn't matter. So I'm going to choose to work with 3 and 12. So I know that 3 is a factor. So 3 divided by 3, 3 divided by 3 is 1. Again, the number I didn't work with, I'm going to circle it and bring it down. And then 12 divided by 3 is 4. Getting close to the end. Notice I have 2 numbers yet I can still work with. I can work with 2 and 4, and I can divide them both by 2. Again, I'm going to circle the number I didn't work with, bring it down. 2 divided by 2 is 1. 4 divided by 2 is 2. Now notice that at the bottom, there are no more numbers that I can work with. Can't work with all 3 of them, and I can't even work with 2 of them. So that tells me that I'm done. And now I can make my letter L. So here are the numbers in my blue L that I'm going to use to multiply out to get my lowest common denominator. Or, sorry, not denominator, sorry, least common multiple. We'll get to lowest common denominator in a little bit. So I'm going to multiply the numbers inside the L. So I'm going to take 5 times 2 times 3 times 2. I don't need the 1s simply because 1 times anything is itself. So I can leave those out. So multiplying those out, 5 times 2 is 10, times 3 is 30. 30 times 2 is 60, and 60 times 2 is 120. So therefore my LCM is 120, which means in 120 more days I'll have a test. I'll have 3 tests on the same day. So that's how you use the ladder method and the LCM to attack a problem like this one with the tests. And again, the process that I use is a little bit tricky. So again, rewind it, go back, redo the problem again with me until you understand how it works. Here's one more problem to try on your own. Use the ladder method that I described to you. I'd press pause, solve it yourself first, and then check for the answer by pressing play. Start by setting up your ladder. I'm going to choose 20, then 40, then 50. Notice that all three numbers end in a 0, so I'm going to divide them by 5. 20 divided by 5 is 4, 40 divided by 5 is 8, 50 divided by 5 is 10. All three numbers can be divided again by a prime number, 2. 4 divided by 2 is 2, 8 divided by 2 is 4, 10 divided by 2 is 5. Now notice that I have three numbers, but only I can divide out 2 of them. 5 is the one I can't work with, but I know that I can divide both 2 and 4 by 2. 2 divided by 2 is 1, 4 divided by 2 is 2, and then I'm going to bring down the 5 that I didn't work with, that I left out. Now notice I can't use any factors of those three numbers, so now I'm going to work with what's inside my letter L. Here's my letter L again. So then my LCM would be 5 times 5 times 2 times 2 times 2. I can leave out the 1. So 5 times 5 is 25. 2 times 2 is 4. 25 times 4 is 100. Times 2 is 200. So my LCM that you should have gotten would be 200.